Welcome back, ladies and gentlemen, to the main stage at the Singapore Week of Information and Technology, proudly brought to you by Enterprise Singapore. Now, we have the next panel discussion. It's called Inventing the Impossible, AI-Driven Materials for a Better World. We're going to examine how AI is reinventing the way that we design, we test, and commercialize new materials. Now, this accelerates the discovery process from decades to now months, and it unlocks massive opportunities to create new industry and reshape existing ones as well. Let me introduce to you our panel. Please welcome on stage moderator, Associate Professor Kedar Hipalga Ongka. He wears many, many hats. He is the Program Director and Principal Scientist at A*STAR, Associate Professor of NTU, and Co-Founder of Synterra. Good morning, sir. And we also have on our panel for today, we've got Dr. Abhijit Vijay Salvakar, Co-Founder and CTO of Polymerize. Good morning. And we have Mr. Dong Hyun Kim, Co-Founder and CEO of NanoForge AI. Annyeonghaseyo. And Dr. Joseph F. Krause, CEO and co-founder of Radical AI. A very good morning, gentlemen. Over to you, Prof.
Thank you very much. It's my absolute pleasure to be here today discussing this very important topic. And I just wanted to set the stage a little bit before I let our distinguished panelists introduce themselves on why we are working on AI for materials, right? So if you think about the materials and chemicals industry, that's 7 trillion GDP per year. That's about 7% of the global GDP per year. And the key is that it's actually underutilized, right? If you actually use AI and robotics, for example, to accelerate this, we could actually take a much larger portion of the GDP. By the way, chemicals and materials is even larger than semiconductors, right? So it's a huge transformative capability. A lot of value is held in many of the industries around the world. It's globally connected. And so it's ripe for transformation. And this is why we are here and working on this amazing idea of using AI to accelerate materials and research. So with this, I'll actually let the panelists introduce themselves, say a little bit about themselves. So maybe start with Abhijit.
Hello, everyone. Good afternoon. So I'm Abhijit. I'm co-founder and CTO at Polymerize. By training, I'm a material scientist. So I did my doctoral thesis at NTU Singapore. And at Polymerize, we are a SaaS platform, AI platform for chemical companies to help them accelerate innovation with the use of AI and help them with their data management. And we are working with, our focus is mainly on the polymers. So polymers is one of the biggest class of materials. You can see all around, like your textile, your shoes, your glasses, then also in terms of your semiconductor applications. So polymers are used everywhere, and this is where today I'll speak more about how the industry and how AI is getting used there. Thank you.
Thank you, Abhijit. Dong Hyun.
Hello, everyone. This is Dong Hyun Kim from NanoForge AI, co-founder and CEO of the NanoForge AI. And it's a great honor to be here with our senior leaders of the material AI fields like Dr. Kedar, Polymerize, and the Radical AI. We are a very young startup from South Korea. We are AI and robotics-based deep tech material research companies, and we are focusing on the ceramic fields at the moment, especially on the battery side. Thank you.
Thanks, Dong Hyun. And Joseph?
Thanks, Kedar. Yeah, hi, I'm Joseph Krause. I'm the co-founder and CEO of Radical AI. We focus on discovering new novel materials and taking those materials from the discovery lens all the way through to manufacturability and shipping those materials into commercial markets. We're about 2 years old as a company, and we're really focused on alloys as a space today.
Right, thank you. So what we have here is an amazing assortment, which is clearly global. So Abhijit here started his company in Singapore, but has tentacles globally in Japan, in Germany, in Qatar, and India. And Dong Hyun is actually starting his startup in Korea, linking with large industry players. And Joseph is obviously based in the US with many, many large industrial partners that he's talking to, especially in military and aerospace and defense, for example. And I myself have a startup here in Singapore called Synterra, and we were founded about the same time as Polymerize, where we work on carbon capture materials. So we develop high throughput and AI for carbon capture materials for fabric. So I think this really sums up the global movement towards AI for materials, where you actually have these amazing transformative startups starting from everywhere, right? So what I will actually do is, perhaps with your experience, some of you are very young, some of you are 2 years old, much older. You're the senior in this panel. Perhaps you can start with what your experience has been. What have you seen are actually transformations in AI and materials from your perspective, and give us especially something related to polymers, things that we can hear where AI can actually transform that particular area.
Sure. So when the journey was quite interesting so far. So when we started 5 years back, this was really new field because that time ChatGPT was not introduced, so people were not really using AI. So AI was not in the hands of normal people that you see around, even researchers. So when we started back then, the main problem, the companies were not AI ready. And when I say they were not AI ready, that means the data. Because data is always like a big problem. They had data of decades, but in different sources, in the different formats, different templates. And collecting all that data, standardizing it, structuring it was the biggest task. And this is what limiting the companies from using the AI. So they were not even ready for AI. But we have seen last 5 years, this has been changing dramatically. Like customers are putting now efforts internally to structure data. And this is what shows their intention, how they are moving to utilize AI. Now, when we see the use of AI or value of AI in this field, it's mainly in the prediction. So can you reduce the number of experiments? Can you reduce the resources that goes into R&D? Because one of the major expenses in the company, whenever there is new application development, it's about how we can go to that application faster, how we can develop the performance, high performance material and more sustainable. So there are many driving forces. So now we are seeing with these driving forces, AI is actually helping the companies. So we have seen cases where we can reduce time by 70% or can save for a project cost over $100,000. And this is what customers are seeing value in at. And that's where they now having internal interest as well to expand or digitalize all across the company or organization. So that has been the change that I've seen last 5 years.
Great. So if I can double click on that a little bit, you're a software as a service company. And so essentially you're trying to accelerate any process and reduce costs, reduce time to market, for example, for products. So how difficult is it not just to get access to the data, but build a general platform that actually serves all your customers in one single shot?
Absolutely, that's a good question. So when we started back in 2020, we spent good 3 years to understand different customers. Because within polymers, there are elastomers, there are coatings, paints, textile, then adhesives. And when we see like the requirements or the usual steps that goes into polymer product developments are quite same. So formulation, processing, and the properties. So this flow is common, but depending on the complexity of synthesis or application development, this can change. So when we see in terms of making it more generic, we customize or we have created customized workflow as a part of our SaaS platform. So customers can start using from day one without any further modification. In case of how data, I mean, initially, as I mentioned, the data, putting data on the platform manually is difficult task. So we automated or built that data structuring pipeline. So we can directly upload Excel, PDFs, and Word documents, and it will structure it into the format that is usable for model building. So it's again like a collective learning from multiple customers across the globe that we could build something generic. And as it is a SaaS and cloud-based platform, there is a lot of collaboration increase within the department. So one of the major expenses or like time-consuming step is people are doing experiments repeatedly because they don't have access to the old experiments or what other users have done or maybe what other location R&D centers have done. So this is what we are tackling with this cloud-based platform.
Thanks, Abhijit, for sharing. It's very interesting, and I think I call it a high touch in materials because every department is different. It's not like saying there's a whole unified system within a company and you can go to them directly and get them to work. So it's definitely high touch. So perhaps I'll pass it over to Joseph because you've been doing this for a couple of years now. So could you elaborate a little bit what AI for materials means for you and what you're working in that space?
Yeah, absolutely. I think there's 3 important themes that we've seen emerge over the last couple of years that we're excited about. Number one is AI, right? 2 years ago, 3 years ago, MLIPs were just coming out, machine learned interatomic potentials, which today are commonplace, I would say, in graduate programs. There's not many PhDs in material science who are not using that technology today. And so we've seen a huge amount of interest come into the AI field out of crossover materials, and that's been exciting. And we're going to see generative models and LLMs, and we're working on them, and everyone up here is working on them, start to become a big thing over the next 2 years as well. So that's trend number one. Number two is robotics. And there has been a huge increase in robotic technology over the last 5 years. What used to be either impossible or very, very challenging from a materials research perspective is now doable. You know, our lab in New York is 100% autonomous. We don't have scientists running experiments anymore. We have robots and AI running experiments. And that's been a big change that not only are we seeing at the discovery lens, but is now working its way up into the manufacturing lens at the material companies. And so that's exciting. And then the third is the material market itself. And so if you look into material science or chemicals at large, these companies are incredibly old. 50, 75, 100, in some cases 125 years old. I don't know many startup markets where that is the incumbent, usually 25 to 50, sure. And so there is this huge opportunity to look into the fragmentation that exists in material science, to think about bridging the gap from discovery to manufacturability and commercialization. And I think that trend, particularly for end markets, aerospace and defense, automotive, energy, these are areas where materials are a bottleneck. There are companies that cannot solve the problem, and the large incumbents don't have the discovery capability to push that technology forward. If you put all three of those things together, we have a perfect storm for an innovation wave to come here, and I think that's why we're here today, and something that as Radical AI we are incredibly excited about.
You absolutely hit the nail on the head here. And your name is Radical, so it's radically transformative.
That's exactly
by definition. So I wanted to follow up on that a little bit. So when you want to hire this, it's obviously cross-disciplinary, right? As a startup, you're investing in AI, robotics, and materials. So what is your strategy then to getting things like the latest large language model or the MLIP integrated into your platforms? How do you go about doing that?
Really good question, especially when you need to build an interdisciplinary team. We have 5 different core technology areas inside the company that we have to hire across and build state-of-the-art technology. That's challenging. It's also a huge defensible moat. There are not many companies in the world that can integrate that many different lenses of technology. And so if you go to a big materials company, they'll have strong material science perspective. They'll have a manufacturability understanding and what they can do there, but they won't have an AI team, or they won't have a software and robotics team, or they really won't have an automation team at all, regardless of manufacture or discovery. That's a huge opportunity for us. And so when we thought about interdisciplinary research, there was this opportunity to say, okay, we can build something different. And then the second thing is perspective. So one thing that we learned very quickly in the AI space is material scientists think one way and AI scientists think a different way. And those are very complementary to each other. A lot of times, I mean, countless number of times in the company, we have seen an AI scientist, for example, say, well, why do you model materials that way? That doesn't make any sense to me. We would never train a model that way. And the same vice versa, where a material scientist will say, I understand why you care about that data. That's not relevant for us, though. That's not going to drive an important property that we want to go sell to industry. That collaboration, that mixing of talent and perspective is really where innovation lies. And so we as a company have had an unbelievable benefit from, you know, going through the hard part of integration, but from that, getting a deep expertise across the board and really going to first principle analysis. And we believe as a company, first principle analysis is really the bedrock of innovation.
It's interesting that you say that. And in Singapore, we've been talking about developing bilingual folks who are able to speak both languages, who then bridge that gap. And that's really a talent that's just emerging, given how young AI and materials is.
That's exactly correct. I think in 5 years from now, there will be PhD programs at the intersection of machine learning and material science. Maybe even sooner than 5 years. I know some universities are already pushing this. It's going to be a big talent wave over the next decade.
Absolutely. So a little bit to Donghyun, since you just started, if I believe, a few months ago, down this path of AI for materials, But you do have a unique differentiator, which is you're integrated already with large companies, enterprises in Korea. So perhaps you can comment what AI for materials means for you, and what intersection are you working at?
So for me, materials means the key to changing the world and the opening the new era. Because obviously every items and every products are made out of the materials. So innovating materials is not just remaining on the material field itself, but it propagate to the relevant industry size. And on top of that, I believe it is important to suggest the future material promising candidates, but also it is important to be a reliable and feasible future materials to be integrated in the industrial fields. So we are more focused on the cooperate and collaborate with the existing industrial players. And fortunately, as we are based on the Korea startup, as you know, like Korea is one of the most advanced and also vertically integrated material ecosystems. So we have a small material companies as well, but also we have a bunch of the big manufacturers in Korea. So our initial goal is to be integrated into their system as a AI material companies. Thank you.
All right. So I think that makes sense. So you're actually building the whole ecosystem, and you feel that you're going to plug into a point where you actually contribute to that vertically integrated ecosystem. So could you expand a little bit upon what you're actually building, and what is your vision for how you integrate AI and perhaps robotics and that particular vertical that you're focused on?
Yes, thank you. So one of our clients asked us to focus on the battery fields, and especially on the batteries which is already in production lines. So what we are trying to do in recent days is we want to suggest solid a combination of the dopants that can easily adapt it to their existing pipelines, which means they don't need to change the pipelines. They just need to change their precursors, which is the material inputs that goes into the pipelines, which is minor change. But we can expect it to be enhancing like 2 to 5% in the battery performance-wise. And also, the other clients are more interested in the generation of the material data itself. As the Avijit mentioned before, in our fields, we don't have a ImageNet or the PubChem like a data sets. So we are very notoriously know of like fragmented data sets, noisy data sets, and unstandardized data sets. So what we are trying to do recently and focus by the December is establishing a fully automated, operatable, automated laboratories, so we can consistently format our data sets and supply to our clients, and also use it for our AI learnings.
I think that makes a lot of sense. I think it's aligned to what Joseph was saying. There's a three different triumvirates: the AI, the robotics, and the materials market. And when you understand each of them really well, that's really where transformation is going to happen. Right? So perhaps what we can do is, given your experience, if you can give us an example, the best example scenario of where a customer was blown away, perhaps, or it saved them time to market, or saved them an immense amount of cost. From your experience, because since you're working on polymers and ceramics and alloys, I think each of those industries, again, are very, very different from each other. So if you can mention, how is it that your technology has helped to transform a particular customer's technology by some factor of 10x or more, or a price point that's much higher, that'll be really useful.
So I'll take example which everybody could relate to. So we are working with one of the leading shoe making company. And now when it comes to shoe, like comfort is one of the most important thing. But depending on where are you using that shoes, either it's for running, it's for walking, or it's for marathon, or it's for sprint, or it's for trail, the material properties define how comfortable it is. So if you're going to wear it for longer time, you need to have that softness. If you're going to wear it for shorter time, you need to, or if you're going to use it for running, you need to save the energy, so higher rebound force or lightweight. So this is like one of the customer case study that we are working, or we have reached to some success, early success. So when it comes, like there are requirement in terms of, you can translate the requirement in terms of mechanical properties. So when we are looking at the shoe midsole, that is one of the crucial part in the shoe. Like what is required is lightweight, then certain modulus, and in terms of mechanical properties like rebound energy, so complex modulus. So when we saw that requirement and we looked through like existing polymers, now it needs to be soft, so there are certain families of polymers. We extracted data from existing patents and literature databases and use that data to build a model to get an initial screening, what monomers can be combined and polymerized together. And based on those results or outcome of that initial literature or LLM based AI analysis, we could choose the monomers, and we are actually synthesizing them back in India in collaboration with one of the synthesis lab. And what we see, the properties that are suggested, recommendations given by AI are actually going in the direction where we want to reach. So it's always iterative learning in terms of AI. You won't be able to reach to the stage. So it's not like you put the data and in the first 5 experiments that you get, you are going to hit target every time. It's always iterative learning. So what AI learns is also from negative experiments, what doesn't work. And this is where we realized, like in first iteration, we were able to reach like 20% exceed than the existing best available commercial polymer. Then to go even further higher for this particular application, we are changing. And this is like what feedback loop. Because when you are developing a product, it's not just the recipe, but how you're processing it. So it's a foaming process, it has its own parameter. And when it has like more than like 20 input parameters that you can control, so it becomes very tedious problem, and this can take without AI more than few years. But we could do it in like few months, and early success we are seeing. And this is just one of the case. We have another case in like backing tape in the semiconductor industry, which has like, we should have zero residual or zero impurity, which can compromise the wafer manufacturing process. We have another like biodegradable adhesives. So one of the thing in the recycling or sustainability, which is very regulated area, and in EU you see have 30% compulsion on using recycle. So when you have these recycled materials, whenever the sources changes, your properties change. So how we can like quantify the changes and how we can, use them or affect them in our tuning of recipe. So this is something that we also tried in the recycling project. So these are 2 success cases.
Yeah, I mean, as a material scientist, I can tell you, getting a 20% improvement in a multi-property system is not an easy challenge, you know. So perhaps that is something that's we should emphasize on. Joseph, do you want to share something about the alloys market?
Yeah, absolutely. So in alloys, it's a really interesting perspective because you have to really identify a material class that you want to move into first, and then also look into the commercial markets that benefit from said material class. So we do a lot of work in what are called refractory alloys, very specific elements in the periodic table that have really interesting properties. And we target properties like corrosion environments, high temperature environments, high pressure environments. These are called in the materials industry extreme environments. And the most obvious application that we are directly working in is nuclear fusion. Now, a lot of the material problems that we want to solve are what we call enabling technologies. We don't really work on optimization-based technologies. And that's where you're driving 1, 2, 5% improvement gain. There's value there. Just as a company, we are focused on unlocking new markets, and nuclear is a good example of this. So inside the nuclear reactor, of course, the materials inside that reactor face really harsh environmental conditions. And we do not have the materials to scale nuclear fusion technology today. And so not only is it a challenge from an energy perspective, it's a really big materials challenge. And so we are working with a lot of companies on directly predicting new materials to solve and survive in those extreme environments. And we've done quite a few of them today and are working on putting them into live testing. A similar area to that is in aerospace. Really big market for advanced materials. They probably spend the most in the commercial markets today on, call these high margin, high product material systems. And they have extreme environments as well. Very fast speeds, which result in high temperatures, high pressures, and that corrosive environment. And so whether it's the Defense Department or commercial aerospace, both of those have been very big for us, and we're in POCs and different type of programs with them on putting those alloys into real tests to see, hey, what's this performance in my application? So those are 2 examples that we focused on today.
Maybe you can expand a little on, you know, so these extreme environments, you cannot run a physics simulation or a digital twin, can you?
You cannot. And if you can, it's at a very elementary level. So you can kind of pick off some properties, elastic moduli or something like that. Knowing how an alloy performs at 2200 degrees Celsius at Mach 5, they're almost impossible to simulate that. And even in the testing side of that, very, very hard to do. It's incredibly expensive. Typically, they're destructive tests. So if it blows up in its test, you really don't understand where the material failed. And so you have to have this very fast iteration speed. This is why robotics is imperative. We need to make thousands of materials to go through this testing, and we make upwards of 20 to 30,000 materials per year to try to get at this problem. So it is a perfect example where extreme environments are exciting from a market perspective. They're very challenging from a materials perspective, and whoever can bridge that gap has tens of billions of dollars of opportunity in front of them. That's what we as a company are focused on and get excited about.
Perhaps, also the enabler is not just the materials, but the hardware that you're building to automate extreme environments is insane. Like NASA, for example, did a lot of work, JPL,
Absolutely.
in order to do radioactive isotopes to go to Mars. Right? And that is transformative technology. So it's incredible that you're attempting this as well. Perhaps, Donghyang, you can talk a little bit about what your initial impressions has been working in the ceramic battery space, and where do you see key challenges being addressed?
Yeah, so as Ajiv mentioned before, we are focusing on the multi-properties as well in ceramic domains. And also, typically recent days, we are focusing on the intermediate physical properties, what we call. Because prediction of the properties is still challenging and important in the ceramic domains. But the previous work mostly done based on the crystal structures and directly into the physical properties. That has been done because we don't have enough data to support and the link on the proper way. So they have to embed the physical and chemical knowledges in the crystal structures, and by utilizing it to predict the physical properties at the end. But we found out most of these predictions were overfitted and interpolated by the data they used for the trainings. So now we want to utilize some of the intermediate physical properties so we can bridge down from the chemical structures, ceramic structures, to our target properties, which means more interpretable, and which is we also can utilize more data sets for these cases.
So we've been thinking about this for a while, which is, we call it a proxy experiment. Right? It's not exactly the property you're interested, because there's no way you can measure failure of a ceramic in high throughput, right, with any robotic system. So you have to come up with some sort of measurement systems that are robotized that give you that data with some variance, and that's really what you want to do, right? Exactly. So maybe we'll take about a minute or so from each of you. I want to emphasize here to the audience that materials chemistry is a very specific field where you can't just go out and make a new material and transform the market. This is not a B2C market where if you have 1 million users or 1 billion users, you generate revenue, right? So you have to then work with these big players globally, right? BASF is a 100-year-old company where a majority of the revenue came from just one process, like the Haber-Bosch process, which has basically not changed in 100 years. They use the same exact catalyst, same exact process for 100 years, right? So how do you see yourself, to start as, what's your strategy to actually understanding this difference in the materials chemistry sector, and how are you going to address that?
Yeah, so we think it's the interconnection of discovery to manufacturing. I love the BASF example. If you go talk to BASF and the scientists there, you'll understand that the processing of said material is where all of that IP value is. And they generate a ton of patent IPs, or IP value, from the materials that come out of that. But it's really the know-how of how to make it at scale with the best margin that they drive value from. And that process is entirely isolated from discovery. And this is why, for the last 100 years, we've had the same exact process and similar or optimized materials coming from that. I don't think there is another industry in technology that has gone that long without innovation. Even semiconductors, which are very hard and very CapEx intensive, have pushed faster than that. And so the opportunity to bridge them is really important. That's where we see the value. How do you take that manufacturability and the process of said manufacturability and start to connect it downstream, or I should say upstream, into the discovery process. That way, when you're doing discovery, you're not just making new materials that you publish in Nature or that you try to get a Nobel Prize for. You're making new materials that have already identified end markets and customers waiting to buy them. Connecting that chain, there is an immense amount of value there. So for us, it's that intersection and really solving the fragmentation problem.
Donghyun or Abhijit, please.
So I'll add, I mean, for this question, I mean, I feel Polymerize is at very right place because we are more downstream rather than directly discovering material. We help the existing material how they can be further improvised in terms of properties. So by modification or by processing it right or by adding different kinds of additives and optimizations. So in case of polymers, like there are already polymers, all the monomers are majorly discovered. Now there are driving forces such as sustainability. You want to change packaging from non-degradable to biodegradable. And this is where companies need to make changes, even the old companies, or they want to use bio feedstock. So instead of using petroleum-based monomers, can they use like ethanol-based from the sugar cane or from plant-based? So this is where they need to innovate and they need to match the properties with existing commercial polymers, and that's where Polymerize platform is enabling them to find alternative materials which are more sustainable or alternative, like one of the major event that happened is PFAS ban, so perfluorocompound ban, and companies were dependent on that material for years and now they want to find the replacement silicon based or other material based, and this is where with our platform they can see, okay, how if you want to formulate the same properties with another material, how can we do it faster? And this is where we use like a molecular descriptors and other things to get to that stage faster.
Would you like to comment on that as well, Donghyun?
Thank you. So I do really agree with what Joseph spoke before. So for that point of view, we are very keen and trying to collaborate with the existing manufacturers. So understanding what they need for the manufacturing and what actually we need to integrate in our discovery phase to be able to feasible and synthesizable materials to support. So thankfully, as we are based on Korea, we already start some collaborations and discussions with big manufacturers, including some small material companies as well. So we are deepening our understanding about how these ceramic materials need to be integrated in their manufacturing lines.
Right, so that makes a lot of sense. Okay, so we've talked about materials. I think the key theme here is if you want to be a startup, you want to commercialize, the manufacturability is really important. This is very specific to the materials and chemicals industry. This is not what you would do with an AI-based company. With that, maybe, let me throw this a little bit of a curveball to you guys, right? If I was a VC today, and and I have 100 million, maybe 200 million to give you, what are you going to do with it? Like, how are you going to change the world? What's your grand vision that you would like to transform the industry we've talked about, which has been unchanged for the last 100 years? Joseph?
You need a lot more money if you want to give us go change the world. I think the big thing to think about is understanding the difference you're going to make as a startup. We talk about this all the time. An investor's job is not to understand the future. An investor's job is to find the people who understand the future and understand if they're the team that's going to go out and build that. And so we always like to talk about you have to deeply understand your industry and more so understand how am I going to change that industry? How is Radical AI as a company focused on making an impact? You need to be very set on what that vision is. The details will change all the time. You'll try this area, you'll switch to this team, you might hire, fire. There's a bunch of different things that happen in that process. But if you are set on your North Star, on your vision, that is what you work towards. And ironically, that's what the VCs actually care about because they don't know where materials are going. And they really shouldn't. They don't spend their life's work or their vacations like we do thinking about materials. We do. And so, I was a VC before. I think the biggest question to ask is, why you? Why is your team right on the vision? And why are you the company that's going to go do that? That's how I would pitch the VC on the future.
Got it. Do you want to chime in?
So yeah, I mean, if I'm getting 100 million, I want to save at least 10 billion using that for other like my customers. and in return I'll get $1 billion revenue. So that should be like a straightforward. We want to use it to make AI more advanced or save our customers like money and resources.
Donghyun.
Shortly, I think we will focus on the robotic system to synthesize and make the data sets affordable. Because, like as we mentioned before, we are kind of feeling a lack of the data sets. So the way we treat the robotic system is not only for the evaluating or validating at the end of the synthesized process, but also we treated them as a generator for our data sets. So probably with that amount of money, we will focus on the robotic system to make and sustainably gain enough data that we can feed our AIs.
Excellent. Thank you very much. The big screen here tells me that we're out of time. I would love to have a chat with you guys. But if you want to hear more, at 2 p.m., they're going to have a focus track, not on the main stage, but beyond stage. So please go beyond stage. I think Radical, Nanoforge, as well as Polymerize, they will be there. So you can talk to them more about materials and how AI is going to transform, AI robotics is going to transform this industry. Thank you all for attending to, this session, and hopefully we catch some of you at the conversation later.
Thank you very much once again to Dr. Joseph, Mr. Donghyun, Dr. Abhijit, as well as Associate Professor Kadar for moderating.